Hello everyone, welcome to Marri Laxman Reddy Institute of Technology and Management. This is S. Rajkumar working as an assistant professor for the Department of Electrical and Electronics Engineering in this college. Today I am going to discuss about the mutual inductance. So the topic name is mutual inductance. In previous lecture, I explained about the self-inductance in a magnetic circuit. Now I am going to discuss about mutual inductance in a magnetic circuit. So here the basic difference between self-inductance and mutual inductance. So both are the same. The property of a coil which opposes the change due to the current passing through the coil, but the self-inductance is due to a single coil, whereas the mutual inductance is due to the two coils which are nearer by each other. So that is only the difference. So let us see how the mutual inductance is produces in a coupled coil. Coupled coils are two coils nearer by each other. So here you can see. So when two inductors or two magnetic coils are close to proximity to each other. Close proximity to each other. That means two magnetic coils nearer to each other. The magnetic flux caused by current in one coil links with the other coil, thereby inducing the voltage in the second coil or latter the coil. The phenomena is called mutual inductance. So the mutual inductance is nothing but, so the consider two coils nearer to each other. Let us see in diagram. So these are the two coils. So it is first coil is supplied by some sinusoidal voltage I of t or sinusoidal current I of t. So because of this supply, current is flowing in coil 1. So these are the two coils nearer to each other. So I am giving supply or current in first coil. That is, current I1 is flowing in coil 1. So there is no coil. There is no supply in the second coil. So whenever the current is passing through the first coil, magnetic flux is produces. That flux, the flux produced by the coil 1. So that is 511. So this is the flux due to the current flowing in the same coil. That too, the flux which is linking with the first coil. And the same remaining flux, some of the flux produced by the current I1 is also linked with the secondary coil, coil 2. So that flux we call it as a 512. So 512 is the flux due to the current in first coil, links with the second coil. Whereas 511 is the flux produced by the current I1 links with the same coil 1. So that is the difference between 511 and 512. So this is a leakage. So this is a flux linking with the second coil. 512 is the flux linking with the second coil, whereas 511 is the flux linking with the coil 1 due to the current I1 in coil 1. So this is the two fluxes. These are the two fluxes here. So according to the Faraday's law, the voltage is induces in first coil is given by N d phi by dt, where N1 is the number of turns in a first coil, d phi 1 is the flux in a first coil, and dt. So this is the rate of change of flux in a first coil. So this we can write P1 is equals N1 d phi 1 by di1 into di1 by dt. So this can be simplified L1 di1 by dt. So this is a voltage induced in first coil due to the current in first coil. So this is a voltage V1 induces in a first coil. So here L1 is equals N1 d phi 1 by di1 is the self inductance of a coil 1. Why? Because it is a current. It is self, the induced EMF, the self inductance due to the its own flux linking with the coil in the same current. So similarly, when flux phi 12, flux phi 12 is the flux produced by the current I1 in coil 1. This is links with the coil 2. The flux is linking with the coil 2. Then there is also EMF is induces according to the Faraday's laws of electromagnetic induction. According to the Faraday's laws, voltage is also induces in second coil also because of this phi 12. So then, V voltage across voltage in a coil 2. The voltage induced in coil 2 V2 is given by number of turns in coil 2, that is N2. The flux linking with the coil 2, that is phi 12 d phi 12 by dt. So this is the voltage. So this can be written as N2 phi 12 by di1 by dt. So this is a voltage. So this can be replaced. So this can be replaced by a constant is called inductance. So that inductance we call it as a mutual inductance. So this is the inductance of a coil 2 because of current flowing in coil 1. So this phenomena we call it as a mutual inductance. This term we call it as a mutual inductance. So this M21 is the mutual inductance of a coil 2 with respect to the coil 1. So that is the thing. So if the open circuited, so second coil is open circuited, mutual inductance or mutual voltage across coil 2 is given by V2 is equals M21 di1 by dt. So this is the voltage or mutual voltage or voltage induced in a secondary coil due to the current in a first coil. So suppose current is flowing in a coil 2. This time, so current is flowing in a coil 2, and while coil 1 carries a no current. This time there is no coil 1. Current in a coil 1, current is flowing in a coil 2. The magnetic flux phi 2 is emanating from coil 2 comprises similarly phi 22 and phi 21. Phi 22 is the flux linking with the coil 2. So phi 21 is the flux linking with the coil 1 due to the current in coil 2. So this is the fluxes. The total flux in a coil 2, phi 2 is given by, so the flux which is linking with coil 1, phi 21 due to current in coil 2. This is the flux produced by the current in coil 2. And that means that it is the same current which is flowing in a coil 2. So this is the total flux in a coil 2. So now the entire flux phi 2 links coil 2. So the voltage induced in a coil 2 according to the Faraday's law. Again, according to the Faraday's law, the voltage V2 is given by number of turns in a coil 2 d phi 2 by dt. This can be written as N2 d phi 2 by di2 by dt. So this can be replaced. This is the constant of proportionality that is given by inductance of a coil. So that is self-inductance. Self-inductance of coil 2. In last class, we discussed what is inductance, self-inductance. Inductance means here the current flowing in coil 2, I2. So flux is produced is phi 2 this flux is linking with the same coil itself. And so this EMF, self-induced EMF, opposes the cause which is producing in coil 2. So that is the meaning of self-induced EMF and self-inductance. Here L2 is a self-inductance of a coil when current is applied to the coil 2 and there is no current in a coil 1. Similarly, flux phi to 1. So this is a flux linking with the coil 1 when current is flowing in coil 2. So then there is a linkage of flux with the coil 1. There may be a voltage induces in the coil 1 according to the Faraday's law, similar to previous case. So here V1 is given by that induced voltage in coil 1 is given by number of turns in a coil 1 N1, D linkage flux. So what is the flux linking with the coil 1 now this time? In this case phi 21. So phi 21 is the flux linking with the coil 1 due to current in coil 2. So here d phi 21 by dt. So this can be written as N1 d phi 21 by di2 di2 by dt. So this is the constant. So this is the constant. This is the opposition for the changes in current in a circuit in a coil. So this property is called inductance. That inductance is due to the mutual flux linking with the coil 1. So that mutual flux, that mutual inductance, we call it as a mutual inductance M12 is given by N1 d phi 21 by di2. So this is a mutual inductance of a magnetic circuit, given magnetic circuit. So in two cases, when coil 1 is carries current, so mutual inductance produces in a coil, so that is M12. M12 is given by here M12 is given by N1 d phi 21 by di2, whereas M21 is given by, so what is previously we are getting M21 is equals N2 d phi 12 by di1. These are the two mutual inductances. So this is the mutual inductance when current is flowing in coil 2. This is the mutual inductance of two magnetic coupled coils when current is flowing in a first coil. So finally we are getting, so V1 is equals M12 di2 by dt. So here two mutual inductances, M12 is equals M21 is equals, I am taking a common effect. So that is mutual inductance EM. Here the mutual inductance is the ability of a, finally how to define the mutual inductance? Mutual inductance is the ability of a inductor to induce a voltage across a neighboring inductor measured in henries. Similar to the self-inductance, mutual inductance is also measured. The units of mutual inductance is henries. So this is about mutual inductance. How the mutual inductance is produces? So the mutual inductance is the phenomena in which the current in one coil produces EMF in second coil. Thereby it opposes the change in current in a coil 1. So that we call it as a mutual inductance of a two magnetically coupled coils. Okay, so this is all about here in this one, in general case, so one coil is there, so this is, we call it as a self-inductance, right? So in last class we discussed about self-inductance. In now we discussed about mutual inductance. So what is the difference between self-inductance and mutual inductance? So the property of a inductor, no doubt at all, in self-inductance and mutual inductance is nothing but a property of a inductance which opposes any changes in a current. So that means that we can say that the sudden changes in current, it opposes the sudden changes in current. But the self-inductance is due to the current in a coil. Current in a coil produces the flux. The same flux linking with the same coil due to the current in the same coil. Whereas in mutual inductance is due to the current in one coil produces EMF in second coil. So that is the mutual inductance. For mutual inductance, there are two coils are required. For self-inductance, only single coil is enough. So that is, in a single coil, self-inductance property is there. In a coupled coils are two magnetically coupled coils. Two coils nearer to each other, there exists a mutual inductance phenomena. So both the properties are same. It opposes changes in a current in a coil in order to bring a current is constant. So that is all about self-inductance and mutual inductance. Thank you all. Thank you very much.